Hey everybody, I wanted to talk about chapter 16, problem number 7. I'm just going to do part A for right now. This talks about, deals a lot with the complex numbers and converting them from rectangular to polar coordinates. I just wanted to go over how to input all this into your calculator because it's relatively simple once you know how to do it. The first thing to do is you need to set up your calculator to do this. So the first thing we want to do is make sure that this is on degrees. This is going to give you the correct number, polar coordinates, and then down here we want to give it into RE theta I. And what that does, if you have a complex number, 15 plus 6i, when you hit enter, it gives you a magnitude and then an angle. Now this angle is above the real line. I'll explain more of that here in a second. So let's delve into this problem here. Now all of this you can input into the calculator except this portion here, which is a little bit more complex, and you may be able to put it into the calculator in that form. I'm not entirely sure. So, but what we want to do is convert this into an imaginary number similar to all the other ones here. And just remember, when it gives you a number and an angle, basically the number is your magnitude. So it's the hypotenuse of a triangle. This is your real axis. This is your imaginary axis. So this distance here is the first number. So say this one was 15 6i, or actually, I mean, we call this j. That's what they use in the book. This was this if this number here was represented here, this would be 15, and then it would go up 6. But that's not what we're doing here. I mean, that's not the same thing, but that's the idea. So to get this from this form, we need to say that a plus bi. And now remember that this is your a, this is your b. And from Pythagoras' theorem and from a little bit of trig, we know that a will equal 18 times the cosine of 40, which is our angle. Here, I need to add that to there, 40. And b is equal to 18 sine of 40. Okay, now I could bring my calculator back up here. 18 cosine of 40, that equals 13.788. 13.78. And then we have 18 sine of 40, and that equals 11.57. Now if we rewrite this equation, what we get is 15 minus 6j minus the equivalent of that. Remember, we have 13.78, which is our A, plus 11.57J, plus 12, plus 8J, over 11 plus 11J. Okay, now we can take all of that and put it into this calculator. So we know we have 15 minus 6j, or I, minus, now you're going to have to get these brackets correctly, minus 13.78 plus 11.5, oops, 57 I plus 12 plus 8i, close that bracket, divided by another bracket, 11 plus 11j, and I might have done this wrong, but we'll see what we get. When you hit enter, there's your answer. Your magnitude is 14.14 and your angle is negative 23.841. So to recap what's going on, basically the easiest way to do it is to convert any magnitude and angle into a real and an imaginary portion, and basically it's just a triangle. That's all you need to do. It's just remember the triangle and remember cosine and sine. If you have any more problems with this, just let me know, but I hope this helped you out.